Okay, today we did an introduction to the chapter on geometry, just mainly refreshing people on what I believe they know pretty well, and proved that the class was in pretty good shape for a lot of the notation and so forth. Okay, well, we have two lines crossing like so. We label points A, B, C, D, E, and we look at some notation, like what does this mean, DC with a bar over it? Well, everybody seemed to know that was a line segment. So right here it is. It goes from D, here it is, from D to C with a bar over it, okay? It goes from this point to this point. The half line DC goes from D to C and keeps going. So the half line is right here in purple, DC with the arrow going this way. We go from D to C and keep going. And DC with the double arrow is just the entire line that contains the points D and C, the unique line that contains the points D and C. This notation means the angle DCE, which is the angle DCE. And you could designate that by a little angle sign here. I've done something similar here. This arrow here, this little arc with an arrow on the end of it, and I could have arrows on both ends of it, but that's angle ECB. So everybody seemed to be comfortable with this notation, so I didn't elaborate on it much. I just refer you to the first chapter of the text, where you can get these and a number of other notations that you're probably familiar with. And if you aren't, of course, I invite questions. Okay, now if I go back to the original figure, because this one's kind of cluttered up, I say that angle ACD, well, I ask the question, what is angle ACD equal to? Okay, well, angle ACD is equal to angle BCE. This angle and this angle are equal, and we call those vertical angles. Again, a notation, I'm not going to bother writing it down because you're probably familiar with it, okay? And also ACB and DCE are equal. So let's see, here's DCE and here's ACB. So this is equal to this is equal to this. And again, there's notation that I believe you understand. If you don't, again, be sure you ask. Okay, so next question, if angle ACD is 30 degrees, then what's angle DCE? If you weren't in class, you want to think that through. But angle ACD is this angle. If that's 30 degrees, we're asking what's angle DCE, this angle here. Well, people were pretty good about that. They said, well, there's a straight line, so these angles have to add up to 180 degrees, and that's exactly correct. So these two angles add up to 180 degrees. And it follows then that angle DCE, if we subtract angle ACD from both sides, is going to equal 180 degrees minus angle ACD. That's 180 degrees minus 30 degrees, or 150 degrees. And of course, you didn't really have to write it out in this case. People pretty much did that in their head. If this is 30 and they add up to 180, that leaves 150. And that's perfectly okay.